welcome to Easy Maths, where we simplify maths to your understanding. Today we're going to be talking about arithmetic progression. Okay. We are going to be looking at arithmetic progression. Arithmetic progression is a topic that's been given to us since primary school, but most don't really take it. Most take it for granted. For example, when we have something like 1, 2, 3, dot, dot, dot. Most students will tell you, okay, after 3 will be 4, will be 5, will be 6. They went on to start teaching, what if we have 2, 4, 6, dash, dash, dash. Everyone knows now they are not counting by 2. So we are counting by 2, the next one should be 8, the next one after 8 is 10, the next one after 10 is 12. However, this is talking about arithmetic progression. The first term here is 2. The first term here is 1. So the first term is always known as our T1, which is our first term. First term is always known as the first term, which means this will be what? Our T2. This will be our what? T3, which is the second term, the fourth term, and on and on. So the difference between them is what we call common difference. Common difference. And it is with letter D. Common difference is D. And the common difference is the difference between each of them. So common difference is T1 minus T2. Our common difference here is 4 minus T2 minus T1. So this will be 4 minus 2, T1. This in turn will give you 2. In case you don't even want to do that one, you can even say T3 minus T2. The end is that our common difference will be common, which is 2. Okay, so let's give an example. Arithmetic progression. Given that 3, 5, 7, dot, 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 105 are numbers in an arithmetic progression, find the first term, the common difference, the nth term, the 15th term, the number of terms, and the sum of the AP. In an arithmetic progression, we have two major formulas. The first formula is Tn is equal to A plus n minus 1D. This is the first formula. Right? The second formula has to do with the sum of nth term, sum of numbers, and that is n into n over 2 into brackets 2a plus n minus 1d, and then we close it. However, this can also be given as Sn is equal to n over 2, which is a plus l. Our l signifies last term. So it's either you use this or this, but this one here, you have to be given the last term to be able to solve. This one you can solve it even without giving the last term. So these are the two major formulas for an arithmetic progression. So let's start. Now, they've given us the numbers. The first one is what we call the first term. The first term is also known as the first number. It is given as symbol A. Alright, so the first term here is the first number here, which is 3, and that's our answer. 3 is our answer. We move on to the next one. Question 2 says we should look for the common difference. The common difference here is the difference between the second term and the first term. The second term here, because this is T1, the second one here is the second term. T2, this is the word T3, and on. So the second term here, this is common difference is equals to is D, which is equals to T2 minus T1. Our T2 here is 5 minus our T1 is 3. So T2 minus T1, 5 minus 3, will end up giving us 2. However, even if you want to use this next 2, that is T3 minus T2, that will be 7 minus 5, which will still end up giving you 2. So our common difference is the same, all true. We move to the third one. The third one talks about the nth term. Nth term now is talking about the formula. And our formula for nth term is Tn is equals to a plus n minus 1d. Among this now, you must be given 2, and we've already gotten our a and our common difference. Our first term, our common difference. So the nth term is another way of saying what is the formula for this major series, alright, or this major AP, arithmetic progression. So to do that, we know that our a is equals to 3 and our common difference is equals to 2. So our Tn will be equals to a now is 3. So we'll put in 3 plus, open our bracket, n minus 1, and then our common difference here is 2. We can expand this. Tn is equals to 3 plus, if we multiply this, expand this, we're going to be having 2n minus 2. Tn will be equals to, this is 2n plus 3 minus 2. And our Tn will be equals to 2n plus 1. So this is our nth term. Nth term, like I said, is a formula. So assuming now we want to get our first term, assuming n is 1. So we put 1 here. 1 times 2 will give us 2. Then 2 plus 1 will end up giving us 3. If we're looking for our second term, it means our n here will be 2. 2 times 2 will give us 4. 4 plus 1 will be 5. If we're looking for our third term, if this is 3, T3 will be equals to 3 times 2, that is 6. 6 plus 1 will end up giving us 7. So this is the formula that can suit in for this kind of arithmetic progression. We move on to the fourth question. The fourth question says we should find the what? The 15th term. The 15th term. The 15th term of the GP. And don't forget that our formula Tn is equals to a plus n minus 1d. So now our n will be equals to 15. Of course, we know that our a is already 3. So here will be what? 3 plus n. Don't forget our n now is what? 15. So we have 15 minus 1. Our d is 2. So we'll fix in 2 here. From this point, our T15 will be equals to 3 plus 15 minus 1 will end up giving us 14. And then we have what? 2 here. T15 will be equals to 3 plus, you don't just say 3 plus 14, we have to use board math here. So 14 times 2 will end up giving us 28. And then when we add it together, T15 will be equals to 31. Okay? So T15 will be equals to 31. However, since we've already solved it before and we've gotten the formula for that, we can also use that to get our answer. Or don't forget our what? Tn is equals to 2n plus 1. T15 will be equals to 2 into bracket 15 plus 1. T15 will be equals to this will give us 30 plus 1. T15 is equals to 31. Don't forget I said this is the formula for this kind of what? AP. And it may not work for others, but it can only work for this one. And now we solve this in 2 different ways. We are getting the same answer. The fifth question is the number of terms. The number of terms, this is telling us that the AP ends at 105. So if we're going to be doing that, Tn is equals to a plus n minus 1d. Okay, in this case, we don't know the term in which 105 stands. So because of that, Tn will take the place of 105. So here will be 105 is equals to our a is 3 plus n minus 1 and our d is 2. So for us to be able to get our n, this we have to move. So we have 105 minus 3 is equals to n minus 1 and then we'll put our 2 here. This in turn will give us 102 equals to n minus 1 and then in bracket 2. At this stage now we can divide all through by 2. This will go and then this will end up giving us 51 equals to n minus 1. If 1 crosses over, our n will be equals to 51 plus 1. Our n is equals to what? 52. So therefore, in this term, there are 52 terms in that AP. So if we continue adding 2, the 52nd term will be what? 105. Another way of solving it is using our number formula. Tn is equals to 2, the one we derived here, equals to 2n plus 1. 2n plus 1. So if we have 105 here, equals to 2n plus 1. This will be equals to 105 minus 1 equals to 2n. This will give us what? 104 equals to 2n. And from here, we can divide all through by 2. This will go and our n will still be what? 52 terms. Okay, so because we were able to generate this formula to suit this AP, that's why we're able to get that as easy as possible. We move to the next one, which is the F. The F says the sum of the AP. The sum of the AP. So the sum of the AP is Sn is equals to n over 2 into brackets 2a plus n minus 1d. Okay, now that we've known the number of times, the number of times is 52. So our S52 will be equals to 52 all over 2 into bracket 2 into our A is 3 plus 52 minus 1, and then our D is 2, and then we can, conclude it here. S this is equals to, we divide this will give us 26 into bracket 2 times 3 is 6, plus this will end up giving us 51 times 2. Alright, and then from here we have 26 into bracket 6 plus, if we expand this will give us 102. Alright, we have the addition of these two will give us 108. Okay, let me pause. 110 and 108 will end up giving us 2808. So if you sum all the APs together up to this point, you add all of them together, it will be giving us what? 2,808 as our final answer. So as an exercise, I want you to try this. Okay, I want you to try this. Given that the numbers in an AP, which is arithmetic progression, are 75, 71, 67, and the last one is 5. Find the A, the first term, B, the common difference, C, the nth term. Don't forget our nth term is also known as the formula. D, we have to look for the numbers of terms. Number of terms in the AP. Number of terms in the AP. The next one I want us to look for is the 21st term. Probably the 21st term. The 21st term. 21st term. And then the last one, sum of the AP. First one, which is A, our first term will be 75. The B will be minus 4. Of course, there's no, we can also get negative for our, our common difference. Our common difference can be negative. Even the first term can also be negative. Alright, so our C, which is the nth term, will be Tn is equals to 4n minus 49. Our nth term will be this. Alright, the D part, which is the number of terms. If you calculate very well from here to this point, we are going to be having Tn to be equals to, or n will be equals to 21. The number of terms will be 21. The next one, which is the E, expected answer for the sum of the 15th term. Our expected answer is going to be 19. T15 will be 19. And then the last one, which is the sum of the AP, that is from the first term to the last term. Our expected answer, sum of the 21st term or 21 terms from 1 to 21, will end up giving us 840. Thank you very much.